Hello and thanks for joining me today. My name is Derek King and I'm a Regional Sales Manager for the Carver Pump Company. Today, we're going to teach you how to size and select the correct pump for an application. We get a lot of questions about which makes one pump better for a job than another, and today we're going to try to give you the tools to make those tough decisions. The first thing we have to do when sizing a pump is ask some questions. What is being pumped? What are the conditions of service? What are the end user's needs? And what type of pump should the customer use? So the first thing we need to find out is what's being pumped. Different fluids require different types of pumps, so knowing what you are pumping is critical. Be sure to ask for things like temperature and fluid properties. This can not only affect the selection of the pump, but also materials and the mechanical seal selection. The next thing we need to ask for is the conditions of service. At the bare minimum, we will need the flow in the head or the TDH, but it's also a good idea to ask for the suction pressure and the NPSH available. This will help us make a good selection. Remember, the more questions we ask, the better equipped we will be to provide a pump that will pump efficiently and last for a long time. We need to understand our customer's needs. A site visit or conversation with your customer can quickly answer questions you have regarding space constraints, what configuration of pump is needed, and what the customer expects for pump life. Next, we should know what type of pump the customer should use. With the information you've gathered up to this point, you should be able to choose the type of pump a customer will need. For instance, knowing that a customer needs a vertical sump pump to sit in a pit can rule out a lot of selections, as there may be many possible hydraulic selections for the same condition. Now that we've answered our preliminary questions, it's time for us to generate a curve. This used to be done manually by looking at paper curves that pump manufacturers publish in their tech manuals, but it is typically done through pump selection software such as PumpFlow these days. Tech manuals with curves can still be found on Carver Pump's website under Resources and Pump Manuals. Carver Pump also offers a free pump selection software on our website under Resources and Pump Selection Tool. Simply create a login, sign up, and get started. After selecting 50 or 60 Hertz operation, you can enter your conditions of service and click the search button. There are other criteria that can be selected, such as pump type or operating speed. Using these criteria will narrow your results. At this point, you have a ton of pumps to choose from. The first thing to do is dismiss the pumps that either don't match the configuration needed or conflict with the limiting factors you have. Things like motor sizing, limited NPSHA, or knowing the desired pump configuration can help you eliminate a lot of these selections. Once you've narrowed down your list of pumps that could work, you need to consider pump efficiency and the spot on the curve where you would operate. The first thing I look at is efficiency. Choosing an efficient pump can save the customer money on their initial purchase as well as their recurring costs. Efficient pumps require smaller, more cost-effective motors. An efficient pump will use less in energy costs to produce the desired flow and head from their pump. Efficiency is very important. The second thing I look at when choosing between pump curves is the spot where the pump will operate on the curve. Every pump curve has a spot where the pump operates best. This spot is called the best efficiency point, or BEP for short. Operating as close to BEP as possible is ideal. While this is not always possible, it's important to know the consequences for running too far to the left or right of BEP. Running to the right of BEP, or having an undersized pump, is not ideal for the following reasons. NPSH required increases the further to the right we run. When NPSH required exceeds the NPSH available, cavitation occurs, which quickly degrades the pump and shortens pump life. Selecting an undersized pump also limits the customer's ability to change the conditions of service to a higher flow rate at a later time. Curve shape is also important to consider. At BEP, a pump curve runs on a nicely dropping slope, but as you go further out on the curve can drop off quickly. This means a small change in flow results in a big change in head. This can result in the pump pulsing and excessive vibration, which can shorten a pump's life. Go too far and drop off the curve, and you may overload your motor or cavitate. Adversely, you can also run too far to the left of BEP and encounter problems. This happens when you select an oversized pump. At the end of the day, we want to select the right pump for our customer's needs. So the most important thing is to talk at length with your customer to understand their needs. Each application is different, and each application has its nuances that experience and discussions with your customer can help you understand. Lastly, if we are replacing a pump in an existing application, ask lots of questions as to why they are replacing their existing pump. If we don't know why a pump is being replaced, we are susceptible to making the same mistakes. From all of us at Carver Pump, I want to say thank you for watching today, and if you have questions, please call, email, or check out our website. Don't forget to follow us on LinkedIn and Facebook, and subscribe to our YouTube page for more pump content. Hopefully you found this useful and are ready to get out there and size some pumps. Take care, guys.